there everybody puts. Why this magical number 0.5? Could be somebody decided in the room and then decided. This is more regulation. So there's no rule of thumb. Okay? So this is how you determine that. Okay? So if anything mm is less than 0.5, your bandwidth is the same as the AM. Just 2fs, which is the lowest where you can go. So for this case, you don't need to use Carson rule. So for narrow band, just use 2fs. Okay? Then for this one, you need to use Carson rule. Again, if it's 0.6, then of course you cannot use Carson rule. They have to draw for it. No, because it's not integers.
Not integers.
Even let's say you realize that okay, they force you to use it, and you ask and they say there's no mistake. What are you gonna do?
Bring it to one nearest.
Okay, not really true, because if it's 0.6, it's quite far from 1. One thing is never write not applicable, because you're not answering, or just not wrong. Yeah, answer. You just write assuming okay, I can use it, then you just put in a 0.6. Okay, and then just apply.
You cannot round it out. More than 0.5.
Means you fail me because I don't know Carson rule.
They cannot use the Carson rule.
You know Carson rule, it's just whether you dare to use it.
Yeah, but you say Carson rule cannot use.
No, what I'm saying is that if nobody, no, okay, there's a thing is that everybody, no one.
We can round it out.
No, there's a possibility if they say what could be the maximum bandwidth. Then you round it to 1, I think, okay. But if they never say that and they just want to find the bandwidth, you still use 0.6. Okay? So in the event where they ask you to use this, and based on your understanding of Carson rule is that I cannot
You have to use integer.
but you don't give it. No, if you don't do it right now applicable, the chances is you get 0. First thing is that first when you say not applicable, most probably you won't even copy down the formula, right? First thing is copy the formula. Okay? Then you can write 0.6, substitute inside, give the answer. If you're not comfortable, you say assuming and rounding it up to 1 so that I can use the Carson rule, just do it again. But that allows flexibility of marking. When you put not applicable, flexibility of marking is this.
So like 0.6, I cannot do say that VFM equal to 4 FM. If the FM is 0.6.
I think the suggestion I have is right two cases. One is 0.6, one is 1.
We are assuming
No, one is 0.6, which is not integer. The other one is an integer. Yes, but you want this allows us to mark. You must think from a marker point of view. I cannot mark it right now. I just mark it wrong one. I can't even continue. But if you force this in, and it could be a mistake, and the examiner say, okay, both will be marked right. But you write nothing, and you cannot move it right. So that is the thing. So this requires a bit of smart way of answering. Okay? Never leave anything blank. If it's 50-50 chance, always guess, not narrow band or wide band. Never leave it blank. Then please, this is technique. You leave it blank is 0. Leave something I can close, 2 eyes, close my all ears and try and figure it out. Okay, now coming to this. Like what they did before, AM has ASK, FM has FSK. Okay? This is more for digital. This is digital communication. The idea is that digital communication means you are transmitting bits. Okay, which means this could be 5 and the other could be 0. So there's only 2 possibilities. Hey, 5 minus 5 or 5 or 0, things like that. So there's only two frequencies inside. Okay? There won't be any third one. So for binary, it's very simple. More straightforward. Of course, binary has different state. They can be multiple states. But for this one, it's very simple. Okay? But you have to be very careful because it's not sometimes it's not obvious. Okay? So this is talking about MSA, MSK modulation. The output is this. Two frequencies. If let's say I have 3 state, 4 state, 5 state, then I could have 5 frequencies. Okay? So these are the transmitting using FM. So they are saying using 2 different frequencies for 2 different logic. Okay, so what are they doing is that as and when you're sending 1, you transmit that. As and when you're sending 0, you transmit that. Everything that we talk about sending frequency is related to the cosine 2 pi f CT. Always. Don't think that I put here FC. How do I pump in frequency? There's no such thing as pumping in frequency. You have to multiply by this. When we put this up to the arrow, short form we put FC is actually multiplying whatever time. Then please remember that.
Do we need to go?
Is it difficult to remember?
Just ask whether we need to.
FSK not so much. But they want to know what is the equivalent of FM, MSK.
So like this one is pumping the FC frequency. Already multiply the input already multiply. FC.
No, because there's no input. The input is being controlled by the switch.
Oh, the input from the switch.
Yeah, no, because the input is controlled by the switch. Sometimes it's on, sometimes it's off.
I thought this way.
No, you see this one do not have a VS here because the electric switch is actually acting like your on-off. And you 110 is just on it for 2 period and then after switch it to 0. Okay? So
Then that one is the output. DC cosine.
yes, this is the output. Okay? They are saying this is the modulator. This is here. Okay? Your control of the switch is actually like your VS.
So the output on the right hand side.
Okay? This is your data control. Okay? Because it's talking about, so inside could be 0, 1, 1, 0, 0. So you leave 0, then you switch to 1, 1 for 2 cycles and then cool down. So it's controlled by a timer. Okay? By the cycle.
Then that one on the is the output.
Yes, it's the output.
The formula here is the input.
There's no formula.
And then VC cosine 2 pi.
Okay. Again, I've been telling you. When you send in FC, there's no such thing called FC. There's no way to pump it in. You need to multiply. Okay, here could be a VS. Okay, here actually is a VC cosine 2 pi FCT. Multiply with this. And then it go up. Okay? So it's always this. Now they're just putting the one there only. With 2 different frequencies. To represent 1 and 0. Okay? When you put FC, it's a shortcut. But it's considered everybody understand. Okay, so this one will be covered inside your experiment. Okay, then this is what I mentioned. You see, this one, if I say it's an AM, you might believe this also. But the thing is that, you need to, okay, first everything has to 0 nicely. Then when you turn it on, you should see whether their frequency is still the same. Okay? The thing is that the amplitude could be distorted due to noise. Okay? So that is why this one doesn't look very, very nice. Okay? Because there's a lot of noise in our electronics. It's not so simple. And so in your experiment, please try it. If you know it's MSK. Okay, let me go into, I'm not going to go into tutorial because I want to finish up the FM, then we can talk about tutorial. is actually too long to cover everything. I'm just needed to cover around half of this. Okay, this is what we have done. So the FC there is not really FC, it's actually BC cosine 2 pi FC2. Okay, we just write this in short form. Okay, so this is what we went through just now. Okay, so this is how they draw 5 kilohertz. What's the unit for the M? You have to switch, sorry. Sometimes it's given as K, sometimes given as M. But what's the unit? It's actually kilohertz per volt. Because it's gradient. It's frequency over voltage. Okay, frequency over voltage. That's why the unit is hertz per volt. Okay, so if they ask you what's the unit for the M or the K, okay, it's this. So the FC is given 100K. So sketch the frequency modulator characteristics. Okay, so this is what you draw. What's the cutoff? This is 100K. Okay, the gradient here is 5K. The minimum of this is 90, and the one on top is 110. Do you know how to get this out? 110 and 90.
Formula. What's the formula?
Yeah, must be. How to get the 110 and 90?
FC 5 kilohertz per volt. So you plus 2 volts, so 10.
Let's plug in on it. What is it? 100K, right? What is it?
5 kilohertz.
5. Okay, the maximum is 2. The minimum is? So this is 210. So you count 110, that's maximum, right? Minimum is minus 2, right? So you multiply 100 minus 10, 90. Okay, that's how you get it. Okay. When you look at the range of the voltage is plus 2 and 2. Don't try and AQ and ask what is the one below. It has to be symmetrical. Plus 2 and minus 2. Okay? Okay, they actually can be different. Actually can be different. Can be 5 volt and minus 2. But they're not so, yeah. Okay, so that's what we try to explain. All this can be given there. Okay, it's all inside. Okay, so nothing is just what we've done. So if you remember this actually is the rest of the form. Okay? Same thing. Okay, calculate Fs at 50 microseconds. First, they will not try and make things too difficult. They either choose the highest or choose the 0 or lowest. Okay, so there's basically 3 points they can choose. Can I put 25? 25 is the highest one, it's 1. 50 is the 0. I can put even 75. So all these things is easy. They wouldn't put something in between. Something in between you need to calculate. What's the value? Okay? So they won't make life so difficult. So at this point, what is Fi? At that moment, you need to calculate. Need to calculate. No? 0, right? What is your VS? 0. So it's don't think so much. Okay, for sine and cosine, they have to ask you instantaneous because it's changing. Okay? For square wave, it's during that whole period, so they're going to ask you, they just ask you the period. Okay? So for this one, they can ask you instantaneous one at that particular moment. Okay, so they show you everything again. This one, if you show me working, actually don't need working. Just write.
Sorry.